Hello, hello. So in this video here, we have been asked to solve the following equation for values of theta in the interval 0 to 2 pi. And we need to give our answers in terms of pi, which is pretty normal for radians. So we're told that cot theta equals root 2 cos theta, and that theta isn't a half or 3 pi over 2. Sorry, isn't pi over 2 or 3 pi over 2. All right, so basically we're going to take this equation and solve it to find our solutions, and then probably use a cast diagram or use a graph to figure out all the other solutions. So if you give that a go, we're first of all going to have to find the solutions to this. So I'd rewrite the cot as cos theta over sine theta. So that's going to be equal to root 2 cos theta. And then to rearrange this, we could kind of divide each side by cos theta. However, that would lose possibly some of our solutions. So we don't want to get rid of the cos thetas. We need to kind of just get it all on one side and probably factorize it. So we can multiply both sides by the sine theta, which is going to give us root 2 cos theta sine theta. Then we're going to take everything to the same side. So let's put everything over to the left. Cos theta sine theta. That's going to be equal to 0 now. And now that these both have a cos theta in common, we can pull that out as a common factor. So we'd have 1 minus root 2 sine theta inside here. And that's all going to equal 0. So that's now really good, because we now have basically our two solutions. If this expression here has to equal 0, then we know that either the cos theta equals 0, or the 1 minus root 2 sine theta equals 0. It has to be one of those things. This itself is sort of sorted. This one here we could do with rearranging. So we say 1 equals root 2 sine theta, or 1 over root 2 equals sine theta. So we've sort of got that now. Then we can solve these. So remember, because they're both trigs, they will have a graph and there will be multiple solutions. So if you grab your calculator, make sure it's in radians, we can do cos to the minus 1 of 0, or arc cos of 0, and that would tell us that theta is equal to pi over 2. And if I just draw my cos graph a second, it'll come down something like that. This value, when cos is 0, and theta's pi over 2, is this one here. And there's going to be another solution, so cos is also 0 over here. So we've got the pi over 2, and this point here, which is 3 pi over 2. Yeah, because it's halfway between pi and 2 pi. So those are our two solutions from here. And then from this one sine, so we can draw our sine graph like that. And we can, in our calculator, do sine to the minus 1 of 1 over root 2. And that gives me pi over 4. Yeah. So my solution is that theta equals pi over 4. And that's going to be around about here. So this is our solution. So we've got two of them, one here, one here. If you're not familiar with this graph method, you can use the cast diagrams. I kind of find this is more helpful, and it's also kind of more conceptual than the cast diagrams, because you actually kind of using understanding of what the shape of the curve is like. So on the y-axis here, this point here is 1 over root 2, and we can see that the curve will be at 1 over root 2, both here, that's pi over 4, and over here, which would be pi minus pi over 4, so 3 pi over 4. So those then will be our solutions. These two and these two. But if we scroll back up to the top, it actually says that theta is not pi over 2 or 3 pi over 2. So really they're saying it can't be this and it can't be that. So these are our only solutions. Yeah, so we've got this one, that's one solution. And this one is our other solution. And that's it. That's this question. So hope that all made sense. If you have any questions, let us know in the FAQ. And otherwise, I'll see you next video. Thanks.